Okay, so we're going to be starting with electricity and magnetism. The first thing I want you to do is to pause and go ahead and take these notes into your Cornell notebook. Make sure you write down all of these learning targets. We're going to be hitting all of them in this week's lesson. We're going to start with a review of what we did at the end of last quarter. So protons have a positive charge and they can't move. Electrons have a negative charge and they can move. For charge, opposites are going to attract, same charges are going to repel. So protons are going to be attracted to electrons, but protons are going to be repelled from other protons. For electrons, some materials allow free movement very easily. These are conductors. Electrons can move very easily through conductors such as gold, copper, and silver, while in insulators, the electrons can't move all that freely. So even though electrons can move, there are some materials that make it easier for them to move and some that make it difficult. For insulators, glass, wood, and plastic make it very difficult for electrons to move through them. Here we have our electric field around our different protons and electrons. So a proton is going to have an electric field that is radiating outward. For an electron, that electric field is going to be radiating inward towards the electron. The electric field is not a force, but it causes forces on electrons and protons that come near it. So if we take a look at this example, we have a proton and an electron. The proton has its electric field and electron has its electric field. And if we introduce different charges into each of the fields, how are they going to act? So pause it, take a second to think about this. For the proton over here, how is this electron going to act? What is the force? Is it going to be forced inward or is it going to be forced outward? Same with the proton here, and then the electron here, and the proton here. So we're going to see that there's going to be a force of an electric force on this electron towards the proton, and then there's going to be a repelling electric force on this proton away from the proton, which makes sense because we know that opposites attract, and then the same charge is going to repel. Same thing over here with our electron. Our main electron is going to repel the electron here, and it's going to attract the proton here. These are the electric forces. These arrows on the outside, that's electric field. These arrows are the electric force. So this is just everything that I wrote down or I said in words. Make sure that you get this into your notes. It's just everything we just talked about. And then take down all of these definitions. Make sure you get all of these into your notes as well. We're going to be talking specifically about current, resistance, and voltage. And I'm going to be using an example of a river and a dam to better explain what those quantities mean and what they are. So first we have voltage. Voltage is a difference between energy from one side to the other. So if we take a look at this dam, we see there's a lot of water here, a lot of water here, and not a lot of water here. So if this dam suddenly broke, we would expect that there's a bunch of water that's going to flood from this end through to this end. That difference in water on each side, that is what voltage is. It is not the water. The water actually represents electrons. It's the difference between how many electrons or how much water is on this side versus this side. So if I had the same amount of water on each side, I wouldn't have a voltage. There would be no reason for the electrons to move from one side to the other. For current, if you take a look at a river, current is just what you would expect it to be. Current is going to be how fast the water is moving, how fast the electrons are moving if that dam were to break. The calm river is low current. There's not a lot going on. The electrons aren't moving very fast, but a rapid river has a high current or high amperes. That is our unit for current. So this one here has a higher current than this one here. Resistance is going to be how hard it is for that water or those electrons to flow in the river. So if there's no rocks, we see that there's low resistance. If there's lots of rocks, we see that there's a lot of resistance. It's not easy for the water to get through this river.